We're now going to go ahead and visualize the search with parallel streams hook methods to see what they're doing kind of from a little bit higher level perspective than just looking at the source code. Of course, we will also look at the source code. As you can see here, the use of parallel streams gives you a substantial boost in performance relative to the use of sequential streams. It's basically a linear speed up in the number of cores, at least on the platform that I was running it on, which was, in this particular case, a quad-core Lenovo laptop with 32 gigabytes of memory, and each core was hyper-threaded, which has a little bit of difference. We'll talk a bit more about hyper-threading later. So here's what processStream looks like when we do it in parallel. So it's input a list of input strings where each string corresponds to a different work of Shakespeare. And then we use the parallel stream hook method to convert this collection into a parallel stream. So we basically end up with substreams with chunks of input strings. And then we end up having the output of this be a stream of input strings, which of course are going to be run in parallel on the different threads and cores under the hood in the common fork join pool. We take the stream of input strings and that gets piped into the map intermediate operation. And what map's going to do is it's going to use the processInput method to search for phrases in a given input string in parallel. So each input string will be searched in parallel, and then within each string, we're going to search for the phrases in parallel as well. So there's a lot of parallelism going on here. This will output a stream of lists of search results. And keep in mind that some of these lists of search results will in fact be empty, because if we're trying to look for certain phrases in certain works of Shakespeare, we're not going to get a match. So we're going to have a list of empty search results. And that'll become important later when we talk about the print phrases method, which is going to be used to go through and get rid of all the empty lists of search results by using the flat map method. So this stream of lists of search results is then going to be directed into the collect operation, and that'll of course trigger the intermediate operation processing to do everything we just talked about, and it'll run everything on multiple worker threads and cores. So if you were to go back and look at the earlier video on sequential streams, you'd see the main difference is that all that processing takes place in a single thread, whereas here we're going to have multiple threads, one thread for every, typically one thread for every core we have in the system by default. And what we end up with when all is said and done here is a list of lists of search results that come back in so-called encounter order. So whatever the order of processing the works of Shakespeare was, be it by date or alphabetical or just randomly ordered at whatever order we happen to have in the file, that's the order we're going to get the results back in. Let's now go ahead and visualize the processInput method. So processInput finds phrases in an input string in parallel. So you get a list of input strings, you get a list of phrases to find on a given input string, like Hamlet, for example. And then we're going to go ahead and convert that list of phrases into a parallel stream of phrases. That will then be output so that we can have all those things run in different threads and cores. And that is connected into the map method, and the map intermediate operation is going to go ahead and take a lambda expression behavior that will search for each phrase in the input string, and that'll all take place in parallel. So we're going to search all these phrases in parallel, and we'll have a stream of search results that comes back from that. And then we're going to take that stream of search results and we're going to get rid of results that are empty. So we're not going to bother storing things that don't have any values. So what we're going to end up with after filtering out anything empty is we'll have a stream of non-empty search results. And this stream of search results will be empty, of course, if there are no phrases that matched in the input string. The terminal operation here, of course, again, is collect, which is going to convert the stream of non-empty search results into a list of non-empty search results, and that'll be passed back to the caller. And that will also take place in encounter order, just because of the virtue of the fact we're using an array list here under the hood, and array lists obey encounter order by virtue of the way that they're implemented. Okay, so we'll get rid of those empty phrases later by using flat map, as we've talked about in the print phrases method. Always remember that the way that the actual processing takes place is not layer by layer. It's really top to bottom, left to right. So I know that that's a little bit unconventional in terms of the way the diagrams look, but just keep that in mind, and that's there as an optimization. And you can learn more about this if you go to the link at the bottom of the slide and find out about that. Okay, so that's the end of the overview of visualizing these hook methods. And this, again, should literally look very similar, to what we did before when we talked about the sequential version. It's just that now these various operations are taking place in parallel, both in terms of the input strings and the list of phrases. So we've got 2 degrees of parallelism taking place in this particular example.